All right, so looking at the kinetic theory and how it relates to solid particles. So like we said, solid particles are going to be closely packed together. They're going to be in a fixed position, and the only movement we have from these particles is that they're vibrating in place. Because they're in such close contact with one another and because they're in such fixed positions, this is what gives solids their definite shape and their definite volume. So I could take a crystal of sodium chloride and place it in a container, and it's going to hold its shape. It's not going to change its shape based off the container I place it in. And this is because of this kinetic molecular theory of solids, where we know they're in a fixed position. And since those particles aren't moving, they hold their shapes. In a solid, because they are so closely in connection with one another, the particles are so condensed and so packed next to each other, they have a very strong force of attraction. Out of all of the three phases, the force of attraction is the strongest in a solid. This force of attraction actually has a name, and you're going to see it come up when we get into bonding. You're going to see it come up throughout the discussion of the phases of matter. It is called intermolecular forces. I'm going to write that term here. It is a term you need to be familiar with. And when we talk about intermolecular forces, we are talking about their attraction to one another. So we're talking about the attraction between two particles. All right. So if I draw two particles, all right, the intermolecular force is their attraction between each other. So this is what are going to make them stick together. So obviously in a solid, because they're in such close contact, it's going to have the strongest attractive forces. Think of a magnet. The magnet gets stronger as you get it closer to another magnet, right? Same thing happens with the attraction. So I have a little model here to show you. You can see we've got some particles and they're packed in a solid. And the green arrows are representing their attractive forces. We know that if you have a positive, it's attracted to a negative. So you can see anywhere you've got a red, which is represented as your positive, your blue is representing the negative charge on that particle. You can see that they're going to be attracted together because opposites attract. You can also see that wherever you have a gray arrow, it's showing you your repulsion forces, which means they're repelling each other. So you're always going to have some attractive forces and some repulsion forces. The more attractive forces you have, the closer in contact those molecules or particles will be. And you can see there's not as many gray as there are green. So that means that the attractive forces overcome the repulsion forces. So this is what happens in the solids. This is why they're so compacted. This is why there's not a lot of space in between the particles. And this is why they hold their fixed positions or their fixed definite shapes.